Good morning, everyone. It's wonderful to be here in Paris, and I couldn't agree more with Donna. It's so great to be here with real people, and not too many masks, so we can interact, talk to people. It's amazing feeling to be here. So great to see you all. So good morning. Great. So I'd like to talk about a little bit about Microsoft's strategy as one of the hyperscalers in the space. What are we doing in IoT? What are we doing in industrial IoT? And then what are our plans with LoRaWAN? So as you know, Microsoft is the leader in industrial IoT. We have been investing billions of dollars, not only in the technology, but also in the ecosystem to build one of the most powerful and pervasive platforms into what we call the intelligent edge and the intelligent cloud. It's a hybrid architecture in which we can run really flexible workloads, cloud-native capabilities, bring them into the edge, and enable an amazing set of capabilities that I'm going to talk about today. And this is a combination of a whole variety of technologies, including IoT stack, including 5G capabilities, including massive amounts of AI and machine learning, and many other things that I'm going to talk to you about. The other thing that I wanted to mention is that, this whole, IoT capabilities that we're talking about, it's underpinned with a really core capability called digital twins. And digital twins is the foundation to the industrial metaverse that we've been talking about over the last year or so. It's a fairly new concept, but it's an amazing concept that unleashes a lot of really powerful set of capabilities. Capabilities such as what you see here, where we are creating a digital replica of the physical world, whatever that physical world ends up being, whether it's a hospital, EV charging station, whether it's a factory, production environment, a warehouse. And the amazing thing about digital twins is that you don't have to disrupt the daily operations of that environment to reimagine how it could be run and what are the amazing things that you could do. And the types of capabilities that we're talking about is it all starts with digital twins, the step number one, where you can model that virtual replica and be able to synchronize it in real time or near real time. So you know what's happening in this digital, replica that you've got. Once you've got that digital replica, the next thing that you could do is that you can start monitoring and managing a variety of things that are happening in that environment, right? It's what we call the ontology, where it's not about a single device within a building, but it's the contextual value of that device with its surroundings. And that's what we call these ontologies that now you can monitor and manage in real time. The next step in the magic is, you take a lot of that information of what has happened in the past, the historical performance, and then you use that to predict the future and create really powerful outcomes that now you know how this machine is performing, what are some of the characteristics of it, and be able to predict any kind of downtime before it happens so you could run these environments in a very efficient manner. And then the ultimate phase in this digital transformation, where I can tell you, not many companies have really reached that stage yet, stage 4 of this digital transformation, is what we call simulation and automation, where not only you can really predict, and run these things efficiently, you can also start simulating the art of the possible. If I'm running a factory and I want to, reduce my OEE by X%, how do I start simulating it based on different types of capabilities, without affecting the daily operations of that production environment or a factory. So, to be able to do that, running these what we call AI-based simulations is really powerful. And we have a technology, with Bonsai that not only we could do machine learning, we can also do machine teaching. Or if you don't have a lot of data, you can teach these machines how they should be behaving and then get into that ultimate stage, which is what we call autonomous operations, where machines are making real-time decisions to run the best performance and output that that environment can produce. So these are the 4 stages of the digital transformation that we're working on in what we call industrial metaverse. Now, let's start thinking about, how does connectivity come into it? Because it's really at the core of it. To date, I can tell you we've been working on some of the most sophisticated environments and machinery that, for example, you can see the picture on the left is a paper sorting, slicing, and it's doing a lot of very, compute-intensive type of operations, and it's a very expensive machine, and the uptime of that machine is really important. Similarly, with highly, sophisticated and very expensive, MRI and diagnostics machine that we're running in healthcare environments. And similarly, we're working on literally thousands of applications in the factory settings with robots and very, time-sensitive type of operations. So we're doing these things today, where we have almost like unlimited amount of compute and storage in the cloud that's doing a lot of the learnings. And then we take these learnings and run them very effectively on the edge. So these things, we're doing it today. But what about, other applications where, that level of sophistication is not available? An example is an orchard where you want to look at the climate conditions to predict what is the best time to pick the fruit, to maximize the profitability. Or what if, you have these massive environments where you have cars in the dealerships and you have them in different warehouses, but it's very difficult to keep track of how many you've got where, with what colors, features, and capabilities to be able to locate them, very rapidly and be able to close that sales cycle. Or what if even simpler conditions where, these trapping devices for mouse and rats, that instead of dispatching people all the time to go around and see when these things have caught something, to only do it when it's necessary and to do it very quickly so, you can be very humane about it. Other applications like, sensing water, the air pressure, and all the different resources that are very important for running a massive wind farm. What about conditions where you're running a high number of apartment buildings or office buildings that it's really important to create a new set of experiences for the tenants, that they feel safe going into the buildings and getting the best experience that there is possible. Like how many people are in the room? How much oxygen do you want to pump in the room to really, give them a really pleasant experience, and not to, run these facilities when there's nobody in them and save energy and cost. And what about the forest? Predicting all the weather behavior and weather changes over time to see what kind of, conditions are happening on the earth, and how do you report it, and how do you keep up with it? There was an example, a great example. I love that video that was shown, earlier today with IoT Thingy, and they're doing really incredible stuff to really predict, the wind speed and the fires, and, not putting the firemen at harm's length, and, the conditions that can really have adverse effects. And, also in the transportation industry, not only keeping track of the vital conditions of the truck, the driver behavior, but also what's in it, or even more importantly for the shipping containers that are, transporting the goods in real time. And, when there's medical supplies, they have to be temperature controlled to make sure that they're done properly. So you can see, beyond the extreme industrial applications that we're talking about, there are thousands and thousands of different applications that we're actively working on at Microsoft that really need a different set of capabilities, a different set of needs, where that compute, that constant connectivity, and the abundance of data throughput may not be there all the time. And then all these other examples that I gave you, the commonality across them are these 4 things. One is that they're not always static. They're moving around, or they're in very difficult areas to be able to get to them. Over millions, or hundreds of acres that you need to have that reach. A lot of them are running on highly constrained battery-operated devices that has to last 7, 8 years. You can't go there and service these things on a regular basis. It has to be extremely cost-effective. We're taking the paradigm of connectivity where I remember it used to be almost like $100 per year to $10 per year to less than $1 per year, right? And then it has to be able to run on very constrained compute devices, that you don't have a lot of compute power at the edge. So either the intelligence has to lie in the cloud or to be able to run very effectively, right? So you can see it's a very different paradigm. And that's exactly why we joined the LoRa Alliance. And we're so excited about this technology because it really helped solve many of those issues that I talked about very effectively. We have joined the LoRa Alliance in full excitement with an amazing set of partners. You can see some of them on this slide, that we have an amazing relationship. And what we want to do is to really integrate our stack, our cloud technologies with what they have to offer. So it really makes it a lot simpler for our customers to deploy these technologies in matter of, going from what used to take months to less than a week to days and hours. That's what we're doing today and making it happen. So, to also tell you exactly how this partnership is working, we've spent a lot of time over the last year, to work on a very effective architecture that takes advantage of, our very complementary set of services. We're working with a lot of different device makers, whether they're in Germany, whether they're in Europe, whether they're in Taiwan, Japan, Korea. So, this capability is innate inside the device. There's no pre-provisioning. You just turn them on, they call home, they self-discover themselves, and the services come on. It's really that simple. And then in our Microsoft Azure stack, not only we have a really powerful IoT platform where today we are connecting over hundreds of millions of devices and ingesting petabytes of data with trillions of messages going in and out. We also have a very sophisticated AI and machine learning stack that can take advantage of all the tsunami of data that's coming in and quickly make sense of it. We have the Power Platform where there are millions of citizen developers today that are developing capabilities with little, low code or absolutely no code. They can get these services up and running, as I said, in a matter of hours. We have a rich set of Dynamics 365 first-party applications like connected field services that, not only you could monitor these devices, then if something goes wrong, if the machine needs service, then we can dispatch the people that can go and take care of them. And most importantly, at Microsoft, we are the most partner-friendly company on earth, or we strive to be. So we are also working very closely with a plethora of our partners and ISVs that have the end applications that we could provide these highly integrated plug-and-play solutions and really have a capability that's ready to deploy for any industry at any time. Very easy to do that. Now, the best way to really tell the story of how these things are working is to do it with our customers. So at this point, I'd love to invite Quentin on stage with me. Good morning, Quentin.
Good morning.
Welcome. Thank you so much for being here with us.
You're welcome.
And taking the late train ride last night. So, Quentin, why don't you start by introducing yourself, please?
Okay. So my name is Quentin, 12 years working for Michelin, 12 years in manufacturing, 12 years in IT. And I'm in charge of the technical IT strategy for the manufacturing. I'm in charge of a team that deploy what we call the foundation, in fact, for the manufacturing. The different components, different bricks we use, in fact, to build our solution or application, like a Kafka bus, Kubernetes platform we host in our factory, and right now, an IoT platform.
Wonderful. So, Quentin, what do you guys do? You make tires, don't you? A lot of tires. like millions.
Yeah.
So tell us, how do you take advantage of the LoRa technology? What problem are you trying to solve? How do you do that?
So, in fact, we need to come back 5 years before. 5 years before, for Michelin, we have launched the digital manufacturing program. We were very ambitious with that. We wanted to get a lot of data from our manufacturing machines, get a lot of data, cross the data from the different solutions we have. And so we have built some factory data lakes based on mainly a big historian named Ozzy SoftPy, and we have linked this historian to a lot of machines. And we were able to get a lot of data, make a lot of progress in productivity, in quality, energy consumption. But we were facing to some limits, in fact, because we were missing some data. And in fact, we wanted to add new data in a non-intrusive way. We did not want to add new sensors to machines, to do automation. We don't want production stoppage. We have decided to move to a wireless solution, and we have chosen LoRaWAN. So we have built a solution, a platform, and we wanted to have an autonomy in our factory for data engineer, data analysts to plug some sensors, to create value, create data for our analysis, in fact. And first, in fact, manual analysis, then advanced analytics by using some tools like BrainCube, DataIQ, the tools we are introducing in our factories.
Excellent. You know, it's funny you say that. We work with a lot of big enterprise companies. We hear that a lot. You know, we go to a lot of massive factories, warehouses, and, you know, it's very difficult to actually go and connect these things. You know, the legacy equipment there are hard to connect. You know, some of the Wi-Fi or 5G or other technologies, they're fantastic, but they're not pervasive and available everywhere. And many of these factories are really in remote areas where there is no cellular coverage. Ooh, look at that. So, you know, to be able to take advantage of this really low-cost, high-reach, you know, cellular technology, I think is really powerful. And I love what you guys have done. Can you also talk about the business value that you're seeing today, and how long did it take you to, you know, get to that value?
So, in fact, the first axis of value we have is to improve quality of our product. And when we say quality, we have a lot of quality control at the end. So, in fact, it's also to save material. And so, I can give some examples. The first one is to add some temperature and hygrometry sensors close to the machine inside of the workshop. Because, in fact, like you know, our tires are made with rubber, and rubber are very sensitive with temperature and hygrometry. So we want to give this data to our data engineer, data analyst, to cross this data and adapt a little bit some recipes. We also know that vibration, sensors of vibration on the machine, we can improve quality of our products. Some other example, it's more about planet. In fact, it's more about energy consumptions. We have added some LoRaWAN sensors to measure the intensity of the electricity coming in our machine, and also some pressure sensors. And we are able to save, in fact, we want to do some stuff about that. We want to save some money, but also to have a good effect for planet with that.
Wonderful. And was it easy to build a solution, you know, together with us and our partner community?
So, yeah, it was a good experience to work together with Microsoft, in fact, and that we have experienced different solutions before in the exploration mode, but finally, in the industrialization, we have decided to choose the Microsoft Azure IoT Edge, Azure IoT F solutions. First, because it's open source solution, and it's one of the directions globally of the IT in Michelin Group. And in fact, we were happy to use that kind of product, the ability to get some LoRa frames, contextualize it, be able to send it to our Kafka bus. The capability of the Azure IoT Hub platform is very interesting to manage your devices, to be able to monitor the different usages we have in the different factories. So it was the reason why we have chosen that technology. It was a good experience because we were able to co-develop and do some evolution in the stack of Microsoft. based on our use cases, so it was very interesting. And what we can say also is it's very interesting for us. Azure IoT Edge will become a foundation for us because we will use that stack not only for getting data, but also to send some images. We have another project named Computer Visions to get images to improve quality also, and we want to use that solution to send data into the Azure cloud. So it's a good foundation for us.
Perfect. So it's real. It's technology is here today, available. Yeah. You built with it, and you're seeing the effects and the advantages of it. Excellent. Well, thank you so much for being here with us. Really appreciate it. Next, I'd love to, yes, please. Thank you, Quentin. Next, I'd love to welcome Remco on stage. Remco, please come on in.
Welcome. Good to be here.
Fantastic. So Remco is another one of our great partners, customers called Heijmans. So why don't you please introduce yourself?
Yeah, sure. So my name is Remco van Woensel. I'm from the Netherlands. I work at the construction company Heijmans, as Tony explained, which is one of the larger construction companies in the Netherlands. And within Heijmans, I work for our smart building solution, which is called Beyond Eyes, which is a service that we provide to our clients.
Great. So Remco, why don't you, same question, tell us about the journey to build this solution. We were just talking backstage, and you were telling me that, you guys are doing all of this. You're doing it, you've got a massive deployment, couple 100,000 sensors, 120 buildings, and you built all of this with a team of 7-8 people, originally with a partner, and then you realize how vital it is to have this technology in-house. So it's not like you have a team of hundreds of people doing this thing. You have an amazing solution with a very small team that you've been able to build in a very quick time. Do you want to tell us maybe a little bit more about, your journey to build this solution and how it all came about?
Yeah, sure. So I think we started Beyond Eyes about 5 years ago as an initiative by, on one hand, the construction company Heijmans that I'm working for, but we did this in collaboration with a cleaning company, also from the Netherlands, CSU. And where we actually started with, okay, maybe if we could measure how a building is used, we can optimize the cleaning facilities, which was relevant for the cleaning company. And for us, it was relevant to know or to learn about how buildings are being used, so we could use that knowledge in building new buildings. And when we started doing that, we actually got the insight, okay, this is very relevant information that we're getting here, that it's not only relevant for us, but also maybe for our clients. And based on that, we started Beyond Eyes, with actually the main focus of us is to building happy people. And what we do is that we have this smart building solution, so we measure a lot of things like occupancy, temperature, energy usage of different components of the building. And we use this knowledge to provide our clients with insights on how well their building is performing, but especially how well it suits the needs of the occupants. And what is, I think, unique to what we do is that we also have these companies behind us that have actual knowledge on buildings and how to organize the services related in these buildings. So we use this knowledge to, for example, advise our clients on how to improve their buildings, but we also have the people and the knowledge to actually make these improvements possible and to execute them as well. So we don't stop at measuring, but we actually improve these buildings and keep using these sensors to monitor how the building develops over time to keep the building staying in fit and in shape, depending on the needs of the occupants that also continue to change through time.
Fantastic. It's really exciting. We're also working with another big developer in New York City that I remember during COVID, when it was a very difficult time, downtown New York City, trying to get people into the buildings. And honestly, people were scared. They didn't know if I should go back to work. So they created this building health index that they took a lot of the vital signs, of how healthy of environment is it. And, are people wearing masks? Are they, following the, 6-foot distance and all those things. And we had another partner that did similar thing for grocery store, to limit the number of people going in and out. And it's just amazing how quickly technology can solve, complex problems like that. And I think you guys went through the same thing during COVID, right?
Yeah, exactly. Yes. So what we saw during COVID as well is that at first all buildings were empty because people were forced to work at home. But afterwards, when people were allowed to come back, there were a lot of issues with, okay, we have to make sure social distancing is also done. So how are we going to monitor that, and how are we going to make sure that people are safe when they're in the offices? So we saw that using these kind of technologies for doing that, but also, for example, with a building that's half empty, you can optimize the energy consumption, improve sustainability. So yeah, gathering all this data and being able to advise our clients on how to make this transition from what we did before COVID and how we're working nowadays has been of big value to them. Yeah.
Wonderful. Well, thank you so much, Remco and Quentin. Please give it up for them, two wonderful partners for us. Thank you. Perfect. So in closing, I just like you to know that, these things are no longer, just technologies for sake of technology. They're not complex. They are solving real problems. They're adding real value. And, people are building them with literally, very small teams of people and getting massive value out of it. So our role at Microsoft, we feel that it's our responsibility to not only endorse this technology, but also create a large community of developers, of partners that can build these solutions and bring it to you, our customers, in a very cost-effective and efficient way. We have a nice collection of technologies, on the cloud side to provide these set of capabilities. And what we're doing right now is not only trying to provide the technology, we're trying to do it in a way that is in the context of solutions. Whether it's modern work, business applications, the infrastructure that can help build it quickly and scale it from one device to millions of devices without people having to worry about it. Having the innovation like digital twins to create these relational databases, to do these complex queries, to have highly sophisticated data and AI and machine learning technologies that can enable metaverse set of capabilities, and all of this with the highest levels of security, which is what is expected of us to bring that confidence to the community. And then the other thing that we're doing is that we have created 5 clouds, one for financial services, one for healthcare, manufacturing, of course, non-profit, where our critical infrastructure is also there, and then also retail. And what we want to do is to also create the network effect, that all these solution catalogs are there from our partner community to be deployed with confidence. And LoRaWAN is one of the amazing enabling technologies that is infused in many of these capabilities that I talked about to make it happen. So thank you so much for listening. We are here to help serve you and the partner community. I have many members of my team here. Please reach out to us, go to our website, and let's go build these powerful solutions together. Thank you so much.